if log base a of x equals 2, log base a of y equals 3, and log base a of z equals 4, find log base a of the cube root of x squared z divided by the cube root of y squared z to the negative 1. Let's begin by combining the quotient here of the two individual cube roots into the cube root of the quotient. So this is going to be equal to log base a of the cube root of x squared z divided by y squared z to the negative 1. Let's simplify this quotient. Since we have z divided by z to the negative 1, this would become z to the power of 2 because it would be 1 minus the negative 1. So this is equal to log base a of the cube root of x squared z squared divided by y squared. Let's rewrite this cube root using a fractional exponent. So this would be equal to log base a of x squared z squared divided by y squared raised to the 1/3 power. Let's continue simplifying this expression on a clean board where I have more room. And so we'll use the power rule to say that this is equal to 1/3 the log base a of x squared z squared divided by y squared. Now we'll apply the difference or the quotient rule, which gives us the difference of log base a of x squared z squared minus log base a of y squared. Now we can apply the product rule, which tells us that this would be equal to the sum of the two individual logarithms. So it's 1/3 log base a of x squared plus log base a of z squared minus log base a of y squared. Next, we can apply the power rule for each one of these individual logarithms. That gives us that it's equal to 1/3 of 2 log base a of x plus 2 log base a of z minus 2 log base a of y. Now, let's substitute the values that we were given at the beginning for each of the individual logarithms. So this is going to be 1/3 of 2 times the value of log base a of x we were given as 2, plus 2 times log base a of z we were told is 4, minus 2 times log base a of y we were given as 3. So this is 1/3 of 4 plus 8, minus 6. So now 4 plus 8, of course, is 12, minus 6 is 6. So this is 1/3 times 6, or in other words, it's equal to 2.